All right, in this lesson, we're going to take a look at what's required to prepare our infrastructure for voice and video. Let's take a look. All right, so CDP is Cisco Discovery Protocol. I bet you remember this from your CCIN or CCNA days. It's a layer 2 protocol used to discover directly connected Cisco network devices. It is, of course, the Cisco proprietary. There is another protocol which is used to discover directly connected devices called LLDP, but with Cisco we use CDP. And essentially, CDP is used for a lot of things. One of the things is for phones to discover their voice VLAN. Now, before we jump in with that, I want to do a quick refresher, make sure we're all on the same page. Switches auto everything by default. They auto speed, they auto mode, they auto duplex. And the important one there is the mode. They want to auto determine if they are a trunk or an access interface. I personally don't like the auto stuff on switches except for speed and duplex. Those are fine with me, but I do not like auto mode. It's a security thing, and I don't want to get into that right now, but essentially you want to hard set the mode. And we want to have VLANs. We want to separate our large broadcast domains and make smaller ones for network performance. Also, by doing VLANs and creating smaller unique subnets, it's easier to identify application traffic like voice and video traffic, so we can do our QoS policies to prioritize that traffic across the network. So there's lots of reasons where we want to set up things like VLANs and also make sure we're not doing auto negotiation of the type of interface we're using. Now, whenever we set up VLANs, if you remember, we have to make sure that the interfaces that we're connecting and we want to assign to a VLAN is an access mode interface. So we don't want to use auto mode to detect the interface because you can't assign a VLAN to an interface with a mode that's set to auto. Okay, so it's got to be an access mode interface. And then we can assign a VLAN to the interface by doing the switch port access VLAN and whatever it is. Now, we use CDP for a lot of things. One of the things is if we want to know which interfaces a Cisco device is connected on or connected to on a switch, we would use CDP, do a show CDP neighbors command, for example, and we could see where the phone's connected. We could troubleshoot if phones are not registering, make sure they're getting their correct VLAN, that kind of thing. Verify configurations, all that kind of stuff. Now, before we would see CDP information, I've had a student actually call me and say, Chris, I'm doing show CDP neighbors, but I cannot see any phones connected to this new switch, and they're saying that the phones are not working at this site. And I'm like, okay, well, and you can't see any CDP information on the switch? He's like, no. And I said, well, is CDP enabled on the switch? And it showed that it was. Well, he had forgotten, and I guess whoever put the switch in, they ordered the wrong part number. It was not a PoE switch. So the phones weren't even getting power, and that's why there was no CDP information. It was the switch wasn't PoE capable, so that's why the phones weren't working. So the first things first. The first thing is the phones do need power to operate. Some more than others, but all of them pretty much, all of the Cisco IP phones need PoE to operate and function. So they get their power, and then they use CDP to detect their specific VLAN. Now, one of the things we do with Cisco infrastructure is we create a special VLAN called the voice VLAN. And we use it for voice and video products as well sometimes. So essentially, this is a VLAN that, whenever we create an access mode interface on a switch, so we've defined these three interfaces as access interfaces. And we'll just say that, this is gig 0, 0, and then we'll say this is 1, 2, and 3. We've done the whole switch port mode access, and we've told it about a VLAN it should operate in, switch port access. Actually, I've already written it here, switch port access VLAN 10. Well, that access VLAN 10 is going to be the VLAN that's used unless there's a voice VLAN configured. So the voice VLAN tag basically says, you know what? If somebody plugs a phone in, assign it to this VLAN, the special voice VLAN. If somebody plugs in a PC, then assign it to this access VLAN that we use there. Now, if somebody plugs in a phone, remember there's a switch port on the back of that phone, and I can connect the PC to the back of the phone. So that should be on the access VLAN, and the switch port voice VLAN would be where the phones should terminate. Okay, so this is a pretty common configuration. You would do switch port mode access, switch port access VLAN 10, and switch port voice VLAN 100. Now remember, the VLANs need to exist before you use these commands. On the newer switches, if you just use a command and say switch port access VLAN 10, it would create VLAN 10 with a generic name. Okay, the correct way to create your VLANs on a Cisco switch is to do VLAN from the global config mode. You're going to do VLAN and the number, and followed by the name. And that's the correct way to create a VLAN. Okay, so for example, I might do VLAN 10 and then name S1 data for like site 1 data or something like that. You can name it whatever you want, but this is the correct way to create the VLANs, and then we assign the VLANs to the correct interfaces, and we use that voice VLAN command to say, hey, if you see a phone here, then give it VLAN 100 instead. And then anything that's plugged in the back of the phone, we're going to give it the normal access VLAN. So that's the voice VLAN, and it's the special dynamic voice VLAN where essentially I can be one of 2 VLANs basically, depending on if I see a phone or not. Anytime other than that, basically, it's 1 VLAN per switch port, unless there's one other way that I might be able to decide what device gets a VLAN, depending on how it's connected, and that's if I'm using 802.1x. I don't want to get into that here. This is a collab course, but I just wanted to mention it because with 802.1x, essentially, we're authenticating our network devices, and then based on that authentication, we can do what's called a change of authorization. And basically, whenever the phone identifies itself as a Cisco phone to the authentication server, then it comes back and tells the switch, hey, that's a phone, put it on this VLAN. So that's another way phones can identify which VLAN is their voice VLAN, right? Another thing we want to make sure of whenever we do our voice VLANs and we configure interfaces for voice is we enable port fast, because we don't want spanning tree making us wait for that interface to come up. This is an access mode interface. We should not be creating loops. So we want to go ahead and use the spanning tree port fast command. And that's just span, and you could do span port fast and that would work. And because it's an access mode interface, that command would work just fine. And then we don't have to wait for spanning tree to listen and learn on the phone before we bring up the interface for voice. Because if a phone resets or something like that, we want it to re-register and be able to make calls and receive calls as quick as possible. Personally, I have one more configuration that I like to do on any access mode interface, and actually any trunk interface too. I'm a big fan of the switch port no negotiate command. And the reason I'm a big fan of that command is because I don't want any of these interfaces ever negotiating DTP, dynamic trunking protocol. I want them to be hard set on what I set them on. Whether it's a trunk or an access interface, I want it to operate like I know it how. I'm a big fan of static configurations, like I said, on LAN devices, on switch devices, except for speed and duplex. Anything else, I want it statically configured. That's just me. All right, so that's we need to make sure these things are set up. That's our voice VLAN. All right, so the other thing we have to make sure is set up is if we want to be able to communicate with our, usually these modern servers, we're going to make this our switch. The modern servers are virtualized. So I may have a number of different servers running on one physical server, as we've discussed, like our BE6K product line, things like that. I may also have a router that's terminating a lot of things for us. And maybe there's a data VLAN and a voice VLAN and things like that. And maybe also I have other switches too. Okay, so the point is, in order for me to pass VLANs from one device to another, or to allow tagged traffic from one switch or device to another, then I have to also have .1Q trunk ports. There used to be two types of trunking back in the day. We've standardized, we use 802.1Q. And essentially, if I want, a voice VLAN down here and a data VLAN there, and I want a voice VLAN up here and a data VLAN up there, then I need to be able to pass information about those tagged packets and tagged frames between each other. So I need .1Q trunking on my trunked interfaces between the switches. And also, don't forget, both of these switches need to have the same VLANs configured. They both need to know about the same VLANs that are in the same switch stack. The other thing is, if I'm doing, let's say for example, I've got one LAN interface and I need to terminate a couple interfaces on my ISR, I may use .1Q here as well, because I could be using sub interfaces or doing what's called a router on a stick to access my voice gateway. And I might have servers that are on different VLANs in my virtual server, so I may be using .1Q here as well. Now again, this is stuff that's more CCNA than Collab, but it is part of this course because you have to be able to understand this and implement this in order to have voice running the way it's supposed to be. All right, so on our trunked interfaces, we want to use switch port trunk encapsulation.1Q. That's our command. That hard sets trunk. We do not want DTP to negotiate a trunk for us. We want to hard configure it. We'll use the command switch port mode trunk. Now on some of the newer switches, you don't have to use this command switch port trunk encapsulation.1Q because the modern switches have standardized on 802.1Q. They don't even have an option for ISL anymore. And then I personally also like the spanning tree port fast trunk because I want those interfaces up as quick as possible, as long as I'm sure that I have a stable infrastructure and I'm not going to be creating loops. You want to use this with caution and make absolutely sure you understand the route switch side of the house before you use that on a trunk, because you could create loops. So use 802.1Q trunked interfaces between switches when connecting to routers with sub interfaces and when connecting to virtualized UC on UCS deployments. That's on our LAN switches. We're going to talk about some steps we've got to configure with our Unified Communications Manager servers right after this.